So here we are with the second and final day of 5.1. Two things sort of to finish up, one of them coterminal angles. So the definition's right there, two angles with the same beginning and end, the initial and terminal sides, but potentially different rotations. So what that means for a full rotation is that we have to go the entire way around the circle. So if we're working with degrees, we would have theta. And then plus or minus so many full turns. So plus or minus each turn is 360 degrees. And then K is typically used to represent like 2 spins or 3 spins. We just substitute that in and multiply our way through. For radians, we can also mark it with a theta. And if you remember from yesterday, radians are in terms of degrees, that back and forth that we did, our little dimensional analysis. Pi radians is 180 degrees, so I would have to double that. 2 pi is the full circle. Also times K, so 2 pi is equivalent to 360 degrees. So for each of these, we're trying to find some positive number less than 360 or 2 pi. So we're essentially trying to get between what we're used to, like a 0 and then up to 360 or up to 2 pi as we work through. And it's just a matter of where you're starting. So for something like 57 and 58, we're beyond 360. So for those examples, I would take my 395 and see how many times I can basically eliminate a rotation by subtracting off 360 degrees is all. So 395 minus 360 would just be 35. And because that then is between 0 and 360, I'm done. And then 415 minus 360 would be 55 degrees. So again, because I am between 0 and 360, I'm done. The difference when you get to something like 59 is that you have negative 150. So because it's already negative, we need to move it in the positive direction. And so instead of adding 360 to somehow get beyond, or I'm sorry, instead of subtracting it, I need to add it to somehow get beyond there. So that would take me to 210 degrees. So these first couple are that easy. 60, the exact same thing would happen. I have a negative 160. I want to add 360 to that, and that would bring me to 200 degrees. So the fun ones are things like 61 and 62 with degrees, and then we'll get into radians. So something like 61, I'll move over here. 61, negative 765. So if I add 360, that's still a negative number. That doesn't get me to where I need to be. That only gets me to negative 405 degrees, which means I need to keep adding. So I need another 405 plus 360. Still not good enough. That only gets me to negative 45 degrees. So this will be my last step. When I take 45 and add 360, that should get me to where I need to go, which is 315 degrees. So when one subtraction or one addition doesn't get the job done, you just have to do it again and again and again, as many times as you need, until you are again between 0 and 360 degrees. For radians, we'll try 2 of these. So something like 63. If I have 19 pi over 6, I have to figure out what this is and where I stand. So radians are between 0 and 2 pi. If you take 19 divided by 6, you get 3 point something. So this is too big. So this would be a rotation over 2 pi. If I'm dividing by 6, I would have to have 12 divided by 6 to get to 2. Rewind that if you need to check those numbers again. So the first thing I did, 19 over 6, is more than 3 pi. So I know it's too high. So I know I need to subtract a 2 pi. And this one will kind of look like magic. So I need common denominators to make this happen. So 2 pi should be something over 6. And so 12 divided by 6 is 2 pi. They're not all going to be that easy where I can just squeeze the extra numbers in. But whenever I do that and subtract, I end up with 7 pi divided by 6. 7 over 6 is less than 12 pi, which is what I needed it to be because that's equivalent to 2 pi for this one. So it's whatever the equivalent one would be. So I stop there. 64 or 65. They're both divisible by 5, so let's try 64, and then you can try 65 on your own. So 17 pi over 5. So this again, and thinking through what 2 pi would be equal to, and I can put it over here. So we had 2 pi for this one is 12 pi over 6. And if I have 2 pi here, it's something over 5. So I would need 10 pi over 5. 10/5 is the same thing as 2. So if I subtract off a 10 pi, then subtracting fractions, really, the pi and the 5 are the same. I need those common denominators in the 5s. So 17 minus 10 is, again, just 7 pi over 5, which is less than the 10 pi over 5, which is my 2 pi. So that's kind of what I'm comparing to. So I know that I'm safe there. So again, we could add or subtract. All these radians one had us subtracting. There were a few extra problems in the book if we wanted to do it by addition. And we could leave these in terms of pi, like I did, or we could convert to decimal points if needed. Okay, so the second half of this second lesson, this is more where we would get into a couple of different word problems. So if we're talking about arc length, I have the picture from the book there so that we can see. So again, it's just that fraction of the circle that we had talked about already. I just wanted to pull this back to geometry because that's a fraction of the circle. Whenever we did this in geometry, we looked at theta as the measure of the degrees out of 360. So we could say, like, if it were 90 degrees, 90 over 360, that's a quarter of the circle. So what fraction of the circle is it? And then 2 pi r is circumference. And so we just took the fraction of the circumference instead. This now, looking at it, we know that 2 pi and 360 are equivalent when we're converting between radians and degrees. So really we've just rewritten this formula instead of using the m like we typically did in geometry, recognizing what theta is as the radian measure instead. And so my trig method here is where we're looking at just, again, s equals r times theta, which we did work with in the first half. So if we're looking at these first couple, find the length of the arc, then something like 71, because of the direction we're working in this time, is as simple as if s is equal to r theta, we are just taking 12 and multiplying it by my radian measure. 45 is in degrees. So to get to radians, that has to be pi divided by 180. So as much as I love to leave things in terms of pi, and we did look at this before, you are allowed to just put this into your calculator and find it in a decimal, rounded to 2 decimal points. But we did this once already. This 45 and 180, that actually becomes 1/4. So this would be like 12 pi over 4 or 3 pi. And so then as a decimal point, bust out my calculator. 3 pi to 2 decimal points would be 9.42. And this would be in inches because this is the measurement along the circle. And so the only thing we really have to watch for with all of these is because these are all in degrees, we have to multiply by pi over 180 to get to radians. So we'll take a look at just one more. Let's take a look at 74. So 74, S is equal to r theta. And be careful, theta does not tell you what the units of measurement are, whether it's radians or degrees. So 74 is 9 yards. And then I would multiply my 315 by pi over 180. And that would give me pi over 360 again. I could make a fraction. It's not the nicest thing ever. It's 7/8, but it's a thing. 24.74 is what I get for this one. And that would be in yards. So those conversions, again, knowing that formula, it's a pretty easy that S equals r theta. So 75 and 76. I have some extra notes down here for that one. And just these 3-word problems. So angular speed. If we're talking about linear speed, we're used to velocity. And so S over T, where we're talking about the arc length, if we deal with just S over time, as opposed to then the angular speed, where we have theta in radians over time. And so each angular speed that we have in revolutions per second, we have to just do a quick unit analysis, or I'm sorry, dimensional analysis, just converting those units. Okay, and my one revolution would be 1 full spin. And so I have 2 pi, because again, that's the full circle, radians in 1 revolution. So for something like 75, if we have 6 revolutions per second, and we have 1 spin would be 2 pi radians for each second, then we have, or each revolution, sorry, we have 2 pi radians per 1 revolution. And so this, again, my revolutions are going to cancel. So 6 times 2 pi is just 12 pi. And then I end up in radians per second, which is my angular speed. That's what I was looking for. 76 would be exactly the same thing. We would just take that 20 and multiply it by 2 pi. I want to take a look and finish us off here with number 92. So the radius of a wheel rolling on the ground is 80 centimeters. If the wheel rotates through an angle of 60 degrees, so if I get my angle on the inside there would be 60 degrees, how many centimeters does it move? So this one, again, this is something that we could have done in geometry. Maybe would have done it in a slightly different manner. I have my 60 degrees. And if I think through what that would be in radians, I have to convert to make it pi over 180. 60 divided by 180, or 6 over 18, reduces to a third. So that angle is the same thing as pi over 3. My length that it's moving then, I would just take S equals R times theta. And so S would be equal to R times theta again. And so we have an 80 centimeter, yes, 80 centimeter wheel, and pi over 3. This one doesn't simplify. It would just be 80 pi divided by 3. So as a decimal point, that's 83.78 centimeters. So a few different types of word problems are involved with this. A lot goes back simply to that R times theta and to recognizing that we have pi radians for every 180 degrees, that's my conversion. So that wraps up 5.1 for us. So again, just a little conversion, a little bit of calculating. Maybe it feels like a little bit of new vocabulary up here with the coterminal angles. And again, just setting the foundation for what we do with all of our trigonometry in the rest of chapter 5.